Hey, what's going on YouTube? Welcome back to the channel. In today's video we're going to build a lithium-ion battery pack using the cells I used to make this battery like a few months ago. And as you can see, this build was not very safe. The cells are a little cramped up. I didn't use the battery cell holders, making the batteries too close to each other. This is not great for cooling. So I'm gonna go ahead and undo this pack right here, and we're gonna reuse the cells and make a better battery pack. This is going to be a 13S 4P battery pack, and these are using Molicel P42A battery cells. These are great batteries, by the way. These are the battery cell holders I will be using for this build. They basically snap into a bigger piece, as you can see here. I already made two for a 13S 4P, and also these are 21700 cells. These are slightly bigger than the usual 18650 batteries. I also really like this BMS I use for this build because it has a Bluetooth module, as you can see here, and this allows you to connect your phone to the BMS, and you can view the charge level and how balanced the batteries are. And as you can see, it does a great job at doing that, as well as displaying the temperatures for two temperature sensors, along with a built-in temperature sensor on the BMS. Next step, I'm going to make sure I test all the batteries, but you may skip this step if you're using brand new batteries. Alright, all the batteries are fully tested and the capacities are marked on the cells. The next step is to go on a website that I will have a link to in the description if you want to use it, because I'm reusing these batteries so they no longer have the same capacities. So basically each set of 4 batteries in parallel should have somewhat the same capacity to the next one, or as close as possible, so the BMS doesn't struggle to balance the batteries. So here is what I'm gonna do. I'm gonna use this website. So the website is called Repackr, as you can see here, and this is what you use to basically sort the cells. It's a really nice website. I will leave a link in the video description if you want to check it out. But you basically go to Packer, and then you will enter all your battery capacities in this box. I have 52 cells, so I'll be entering all the capacities of the 52 cells in here, and then I will separate them with a comma, and then I will hit add cells. So I laid out the batteries like this. I have 52 batteries in total. I had to replace 2 of the batteries because these were going bad. No wonder the battery pack had hard time balancing. It took forever. Now I guess I will no longer have the issue. But yeah, as you can see, here are the cells. I will have a 13S4P, meaning 4 cells in parallel, and then 13 sets in series. These are 3.6 volts nominal cells, so this is going to be a 46.8 volt battery pack nominal. So yeah, let's get right into it. Alright, so after entering all the cells capacities, we're gonna go ahead and hit add cells. Now we go to stage 2, specify pack dimensions. Here you're just gonna go ahead and enter the number of cells in series. In my case it's gonna be 13. Here you can decide to enter the number of cells in parallel or the milliamp hour. Here I'm gonna put the number of cells, which is gonna be 4. This way it's gonna use the capacities I entered to compute the actual capacity of the pack. Now we have the nominal cell voltage, which is 3.6. It's 3.7 for some cells. I'll also keep the number of cells to fixed, not variable. And then we're gonna go ahead and hit generate packs. Alright, this is gonna take us to stage number 3, as you can see here. And then we have a summary of everything we have. A nice layout of how we have to set up the battery pack. It puts 4 cells together. These are gonna be the cells that I have to assign to each group of 4 in parallel. And I will have a great capacity. It even tells us the capacity of the battery pack, the watt hour, and the nominal voltage. Alright, so yeah, let's go ahead and use these and assemble our battery pack. Alright, as you can see on our first pack, we have the battery with the capacity 3639, 3528, 3436, 3356. These are the 4 cells that I have to put together for the first set. So let's find them. Alright, now I can go ahead and assemble the batteries, and I'm going to do this for all 13 sets. Alright, now we're gonna mount the top part right here. Sometimes this part is a little bit tricky. Alright, now we have a better looking battery pack. This is neat, as you can see, much more solid than what we had before. So now all we have to do is go ahead and spot weld this. I will be using the K-weld. As you can see here, I reviewed this about a few years back. I would pin the video on the top right if you want to check it out. It's a decent spot welder, really nice. It takes a 12-volt battery, so I'm using my DIY battery pack to power it. I also pinned a video of how I built this battery on the top right if you want to check it out later. So we're gonna need some 21700 nickel strip. I have some here. I don't know if this is gonna be enough. I just ran out of the nickel strips for the 21700. I'm gonna have to improvise with the straight nickel strips. Can't use this because it's for 18650s. We are done with the spot welding. So as you can see here, I also welded some tabs for the balance wires. The next step is to go ahead and wire the BMS. Alright, we're at 53.7 volts, a fully charged battery, almost. Fully charged voltage is 54.6. Alright, battery pack is mostly done. I just hooked up the temperature sensors, one here and the other one here. Now we're gonna go ahead and connect the balance leads. Alright, we are all set. Next step, I'm gonna use the Kapton tape to hold the wires in place. 53.7 volts. Our battery pack is ready to be used. I usually wrap it up with shrink wrap. I don't have some. I'm gonna have to order some and then shrink this down. To connect it to a smartphone, I basically use Overkill Solar. It's gonna scan and find a list of the BMSs available. This is the closest BMS, and as you can see, it will have the strongest signal. Let's go ahead and select it, and as you can see on the battery, that blue LED turns on, meaning that we are connected to that BMS. We have the battery cells right here. Everything is working perfectly fine. The battery is almost fully charged, but it's showing half voltage because I haven't set it up yet. You're gonna have to tell the BMS. You're gonna have to let the BMS know the capacity of the battery. So you go to the settings right here, and then you're gonna enter the capacity of the battery pack. In our case, it was 14 amp hour. So we will go here, and then we will put in 14,000 milliamp hour, and here 14,000 milliamp hour. As you can see, the number of cells is correct, and then we're gonna go ahead and upload. Unless you like to have an offset between the total battery capacity and the cycle, then you can put less. All right, now we can go back to the battery, and as you can see, now it shows a fully charged battery pack. So we are ready to go. Here you have two switches. This is for the charging switch. You can turn off charging. This way, when you connect it to charge, it's not going to charge. For that, you're going to have to turn on charge. You also have a switch for discharge. And if you turn off discharge, no power comes out. And to get power out, you're going to have to turn it on again. But as you can see, it's straightforward. You have your power here. When you're using the battery, it will show the amount of current being drawn as well as the power. All right, and as you can see a battery charge in percentage. You see the voltage as well as the capacity at the bottom right here. So when you're charging, it will show you the current right here, and when you're discharging, it will show you the current draw right here. All right, as you can see here, I have it connected and it's charging at 3.76 amps. It's almost fully charged. That's why the current is dropping. And as you can see, the power at 185 watts. I have the battery powering my generator. This is a DIY AC power station that I built on this channel. I will pin the video of it on the top right if you want to check it out. So I have it powering a heater and a light. As you can see here, it's drawing about 1175 watts, and as you can see on the app, it shows that it's drawing 1272. So if you consider the loss and everything, you will see that it's very accurate. And as you can see, we are drawing 25 amps right now, and we can also see the voltage drop right here, as well as how balanced the cells stay throughout the discharge cycle. Building a battery pack is really easy and straightforward. You just need to know how to wire the balance wires. So what you have to do is basically connect the negative black wire to the far negative of the battery pack, which is going to be on battery 0 right here. And then the following white wire goes to the positive of that cell, and the second white wire goes to the positive of the next cell, and so on until you reach the red wire, which is going to end up on the far positive of the whole pack. So it's really straightforward, but yeah, let me know in the comment section if you have any questions. I always respond to the comments, so let me know if you have any questions, suggestions. But yeah, thank you for watching this video. Hopefully you learned something. Remember to hit the like button, subscribe, and stay tuned. Thank you for watching, and I will see you in the next video.